Imagine teaching a computer to learn, not through rote instructions, but by enabling it to recognize patterns and make decisions on its own. Just like we teach children by providing examples and guiding them, machine learning involves training computers to understand and adapt. This is the essence of machine learning, empowering machines to learn from data and improve over time without being explicitly programmed for every task. Within this fascinating field, there are different ways we can guide a computer's learning process, each tailored to specific types of problems and data. Two primary categories stand out: supervised and unsupervised learning. These methods define how we approach teaching machines to interpret and analyze data. These approaches form the bedrock of how we build intelligent systems, enabling them to solve complex problems and make informed decisions. Supervised learning is akin to learning with a teacher, where guidance and feedback are provided to ensure the right outcomes. We provide the computer with labeled data, essentially giving it the right answers to learn from, much like solving a puzzle with a clear picture as a reference. The computer then learns to map inputs to outputs, enabling it to make predictions on new unseen data with remarkable accuracy. On the other hand, unsupervised learning is like exploration without a map, where the computer navigates through uncharted data. We present the computer with unlabeled data and task it with finding patterns, structures, and relationships hidden within the information. It's a journey of discovery, where the computer uncovers hidden relationships within the data itself, revealing insights we might not have noticed. Understanding these two fundamental learning styles is crucial for anyone venturing into data science, as they form the foundation for more advanced techniques. They are the building blocks upon which more complex machine learning concepts are built, paving the way for innovations in artificial intelligence and beyond. In supervised learning, we act as mentors, guiding the computer with labeled data. This data serves as a foundation, helping the model understand the relationship between inputs and outputs. By providing clear examples, we enable the computer to learn patterns and make informed predictions. Think of it as providing a student with a textbook and answer key. The textbook offers the knowledge, while the answer key ensures the student knows the correct answers. This combination allows the student to learn effectively and build confidence in their understanding. The textbook contains the input data, while the answer key holds the corresponding correct outputs. Together, they form a complete learning package, guiding the model step by step. Let's illustrate this with an example: predicting housing prices. Housing data is a common use case for supervised learning, as it involves clear relationships between features and outcomes. Imagine we want to build a model that estimates the price of a house based on features like its size, location, and number of bedrooms. These features act as the input data, while the actual selling price serves as the output. In a supervised learning scenario, we would train our model on a dataset where each house's features, such as size, location, and bedrooms, are paired with its actual selling price. This pairing is crucial, as it allows the model to understand how different features influence the price. The model learns from this labeled data, identifying patterns and relationships between the features and the target variable, the house price. Over time, it refines its understanding, improving its ability to predict accurately. Once trained, our model can then predict the price of a new, unseen house based on its features. This process demonstrates the power of supervised learning in making data-driven predictions. This ability to generalize its learning to new data is a hallmark of supervised learning. It showcases how models can apply their training to solve real-world problems, making them invaluable tools in various industries. In contrast to the guided approach of supervised learning, unsupervised learning thrives on exploration and pattern recognition in unlabeled data. It's like giving someone a jigsaw puzzle without the picture on the box. Imagine you're a retailer with data about your customers' purchasing habits. You want to understand their preferences better and segment them into groups with similar buying behavior. This is where unsupervised learning shines. By applying an unsupervised learning algorithm like clustering to your customer data, the algorithm can identify natural groupings within the data based on patterns of purchasing behavior. This segmentation can then inform marketing strategies, product recommendations, and customer relationship management. While supervised and unsupervised learning form the core of machine learning, other learning paradigms exist. These include semi-supervised learning, reinforcement learning, and more. Semi-supervised learning, as the name suggests, falls somewhere between supervised and unsupervised learning, leveraging both labeled and unlabeled data. Reinforcement learning, on the other hand, focuses on training agents to make sequential decisions in an environment to maximize a reward. While these approaches are fascinating and powerful, grasping the fundamentals of supervised and unsupervised learning is paramount. They provide the foundational knowledge needed to understand and appreciate the nuances of these more advanced techniques. Mastering the basics of supervised and unsupervised learning is akin to laying a strong foundation for a house. Just as a house relies on a sturdy base to stand tall and weather challenges, your journey in data science depends on a deep understanding of these core concepts. Without this foundation, even the most advanced techniques can falter. These concepts are fundamental to the field of data science and serve as stepping stones to more complex algorithms and techniques. They provide the framework for understanding how data is processed, analyzed, and transformed into actionable insights. A solid understanding of these learning paradigms allows you to approach problems with confidence and clarity. It equips you with the tools to break down complex challenges into manageable parts. First, choose the right approach. Whether you're working with labeled data or exploring patterns in unlabeled datasets, knowing when to apply supervised or unsupervised learning is crucial. Different problems call for different solutions, and the ability to discern which method aligns with your data and objectives is a skill that sets you apart. Understanding the strengths and limitations of supervised and unsupervised learning helps you select the most appropriate technique for a given task. Second, interpret results effectively. This step is often overlooked but is vital for deriving meaningful conclusions. Interpreting the output of a machine learning model requires a clear understanding of how the model was trained and the type of learning it employs. It ensures that the insights you derive are accurate and actionable. And finally, build a strong foundation. This foundation is not just about knowledge but also about cultivating a mindset of continuous learning and adaptability. The principles of supervised and unsupervised learning underpin many advanced concepts in data science. They act as a bridge connecting foundational knowledge to cutting-edge innovations. By mastering these principles, you lay the groundwork for exploring more sophisticated techniques, making them essential building blocks for further learning and success in the field. Just like a musician masters their scales before composing symphonies, a data scientist must first grasp the fundamentals of supervised and unsupervised learning before diving into more advanced concepts. These two pillars of machine learning provide the bedrock for understanding how machines learn from data. With a solid grasp of these concepts, you can confidently approach a wide range of data science challenges. Remember, the journey of 1,000 miles begins with a single step. Start with the fundamentals, build a strong foundation, and embrace the exciting world of machine learning. The field of data science is ever evolving, with new techniques and algorithms emerging regularly. However, the core principles of supervised and unsupervised learning remain timeless. So, embrace the learning adventure, delve into the fascinating world of machine learning, and unlock the power of data to solve real-world problems.